In this video, we look at the gas laws. An ideal gas is a gas that exhibits the 5 postulates of the kinetic molecular theory as well as obeying the gas laws. The gas laws, Boyle's law, Charles' law, and Gay-Lussac's law, describe the behavior of a gas when subjected to change in temperature and pressure. Boyle's law. Boyle's law, named after the Scottish scientist Robert William Boyle from 1627 to 1619, states that at constant temperature, the pressure and volume of a fixed mass of an ideal gas are inversely proportional to each other. So if the pressure of a fixed mass of gas at constant temperature is doubled, then the volume halves. As you can see in this diagram, when you apply pressure, the particles will come together and the volume will decrease. So mathematically it's expressed as PV is equals to K, or P is inversely proportional to volume. So graphically this is what Boyle's law looks like. Since pressure and volume are inversely proportional, as volume increases, as you can see, the pressure decreases. The pressure is decreasing as the volume is increasing. But when you are plotting pressure against 1 over volume, the graph is linear because they are both increasing. So 3 things you should take note of in gas law. The first one is temperature must be in Kelvin in calculations. Kelvin is the science of temperature, so you have to convert Fahrenheit and Celsius to Kelvin, and to change from Kelvin to Celsius, use this formula: K is equals to C plus 273.15. So in the exams, mostly you'll be given in degrees Celsius, and Fahrenheit is rarely used, especially in the IB diploma. And absolute zero or 0 Kelvin is the lowest possible temperature on the Kelvin scale. So Charles' law. Charles' law states that at constant pressure, the volume of a fixed mass of an ideal gas is directly proportional to its absolute temperature in Kelvin. So at constant pressure, the volume and the temperature are directly proportional, and it's given to us by this formula here. And the graph, as expected, is linear. As temperature is increasing, the volume is increasing. Another thing why we cannot use the Celsius is when you're trying to plot the graph, the line will not pass through 0, because 0 Kelvin is the same as minus 273.15 degrees Celsius, so it's not going to pass through 0. So that's why it's convenient to use Kelvin and not degrees Celsius when you are trying to calculate the gas laws. And Gay-Lussac's law. Gay-Lussac's law states that at constant volume, the pressure of a fixed mass of an ideal gas is directly proportional to its absolute temperature. So when the volume is constant, the pressure is directly proportional to temperature, and it's given to us by this formula is equals to K, where K is constant. So lastly, we have the combined gas law. These 3 laws are often combined into one expression, and the combined gas law is represented as this: PV over T is equals to K, where K is constant. And you can also write it this way. And why did we combine it? Mostly in the exam will be given the P1, V1 and T1, also V2 and T2, and you'll be asked for P2. So this is the formula you can use in order to calculate P2.